Okay, ma'am.
Yes, sir.
Okay, ma'am.
A very good evening to one and all. I welcome all the participants for the second day on this 5-day online FDP on advanced signal processing communication using AI and ML. So for this session, we have with us Dr. T. Geetama Madam. Presently, she is working as a senior assistant professor in EC department of GMRIT. She is having 20 years of teaching experience in engineering colleges. Her area of research is image processing, and she is having more than 25 number of publications in various journals and conferences. And she also delivered more than 10 talks in various faculty development programs as well as in workshops in the area of image processing. Now I request Dr. T. Geetama ma'am to take over the session.
Good evening to one and all. Thank you, ma'am. First of all, before going to start my session, I would like to say thanks to our departmental HOD, Dr. Jagan Naveen sir, and our convener, Dr. V. Kannan sir, and coordinators. I'm so thankful to you for giving this opportunity. Thank you, ma'am. So today I want to give a presentation on deep learning based medical image segmentation methods. Yes, deep learning based medical image segmentation methods. If you observe this title here, there are three important words: segmentation, image segmentation, and medical image segmentation, deep learning methods. So these three are a very important terms. Okay. So first of all, I want to show that the contents which will be presented in this session, the medical image segmentation, deep learning, image segmentation based on deep learning, and these are the important methods for this today's presentation. Fully convolution neural networks. There are some four methods: deep lab V1, deep lab V2, deep lab V3, and V3 plus.
Excuse me, your slides are not.
Ma'am, Geetama ma'am, your slides has not been shared.
Oh, I'm sorry, ma'am. Now is it visible to you, ma'am?
Yes, ma'am. Yes.
Yes. Yes, sir. This is the title of today's presentation: deep learning based medical image segmentation. And these are the contents to be presented in this session. The medical image segmentation methods, the fully convolution neural networks. In this, there are some four methods are there. And here UNet, this is a very important for medical image segmentation. And third one is JAN. And here fully, before going to explain about these methods, I would like to explain about the neural networks, convolution neural networks, and fully convolution neural networks. And then I want to explain these methods. There is a difference between the convolution neural networks and fully convolution neural networks. And first of all, full connected networks, full connected neural networks is different. And full convolution neural networks is different. CNN is different. And fully convolution network. No, different means in the application point of view, we can show that. Here, full connected neural networks. CNN is used for image classification. And for segmentation, especially for segmentation, we have to go for the fully convolution neural networks. And here also deep lab V1, V2, V3, V3 plus, and all these methods are there. Just there is a difference between the structure only. And now coming to this segmentation, image segmentation. The goal of segmentation is to simplify or to change the representation of an image into something that is more meaningful and easier to analyze. Image segmentation is typically used to locate the objects and boundaries like lines, curves, etc. So this is the goal of image segmentation. And if you observe this picture, here in this picture, there are some objects. These objects are of different size. See, coins are there of different size. Okay, of different colors. From the background color is a black. And if you apply the image segmentation on this image, what is an output? So how can you define the segmentation? No, we know the segmentation, the goal of segmentation. Now, what is image segmentation? How can you define it? This image segmentation is nothing but divide an image into some disjointed regions, and each region should have a same pixels. This region should have a same pixels. That means gray levels. This circle is having one color means it indicates that it is having the same gray level, and this circle is having this color means it is having same color, and the background is completely black. So there are some different objects, and each object is considered as a one region. One region means it is having a similar gray levels. So now the segmentation is defined as a division of image into several disjointed areas according to features such as grayscale, color, texture, spatial texture, geometric shapes. As I told you, based on this geometric shape, grayscale, here the background is black and the coin is having a different color. So in that way, there you can tell that there is a discontinuity in the gray levels. Here the black is having a 0, for example, 0 to 255. If you consider that is a monochrome picture, 0 is for black color, and suddenly at this edge of the object, there is a discontinuity in the gray level. That is called detection of. So here the discontinuity in gray level, sharp change in gray level. And after entering into this object, there is, if you find that they're almost all are having the similar values. So that is called slowly varying gray values. Based on these two, the segmentation is happening. And now coming to the methods of image segmentation, semantic segmentation, instant segmentation, and panoramic segmentation. So the semantic segmentation is the important one in a medical image processing. Here, semantic segmentation of medical image is regarded as a semantic segmentation task. Now, in this session, I'm going to give a presentation on semantic segmentation. And there are some research branches of image segmentation. What are that? Generally, we know that satellite image segmentation, medical image segmentation, autonomous driving, etc. There are so many research branches are there. And now, why is image segmentation necessary? If you observe this picture, are you able to find the solution, the importance of segmentation here? At least we can define the segmentation once again here. Here, this is an image which is having the different objects like a trees. There are trees and there are some bikes. This is one object. This is a bike again. And there are some persons in these regions. Okay. And the another object like a road is there with this gray color, with this color. So now the segmentation, as per the definition, according to their features, we have to do the segmentation. Features like a grayscale, the color, spatial texture, and geometrical shape. Now in segmentation, what will be the output? Different objects are there. The different objects are identified with their areas occupied by their areas, just like this. See, this person with the blue color is indicated for person, light blue is for grass, tree, green color. In that way, the segmentation output. Now, are you able to understand the importance of segmentation from this image? I think that purpose is not satisfied here. So now coming to this picture, first, why is image segmentation? It's important in a face recognition, number plate identification, image based search and medical image. If you observe this picture, now you can tell that there is a lot of there is need is there. Image segmentation need is there in this image, because if you observe this picture, this is a medical image of our brain. And if you observe that this image, as per my title, image segmentation is it plays a very important role in medical images, especially. That's why I'm telling that in previous images, if you observe this image, that importance cannot be clear here. Here now, if you observe this picture, this is a medical image. In this medical image, see, what will happen actually in the as per the procedure, the doctor will see this image. This is a image obtained by the medical test. Okay, that doctor can identify that there is an abnormality as per his perception. As per his perception and his knowledge as a medico, he can identify there is an abnormality. See, this red region is an abnormal region. Now, that I think it is based on his knowledge only. If doctor could not able to do this, means the diagnosis will fail. If doctor is okay, he has a more knowledge on this one, okay, the patient will get a benefit. Now, nowadays, the segmentation methods will help the doctors by reducing their workload like this. See how this segmentation result will happen. Then after segmentation, the segmentation is based on grayscale, color, special texture and geometrical shape. So we may not be able to identify these colors, but as per this picture, there is a difference in grayscale. As per the difference in grayscale and all these features, they have identified like this green color belongs to one region. Okay, and the yellow color is there that belongs to one region, and red color is there that belongs to one region. They have this segmentation methods have identified like this and assigned the colors. So what is there here? Actually, that green color is like an edema. Edema means unwanted water occupied in that brain. And yellow color is an advancing tumor. Advancing tumor means generally in a cancerous cancer patients have a cancer tissues that are spreaded into from one body part to the other body part. Like a breast cancer, if a woman got a breast cancer, that tissue, that cancer tissue or a tumor is spreaded into that, immediately spreaded into that chest area through the bones and then lungs and that stages, third stage, the doctor said no, second stage, season, second stage, third stage. The stages are depending on this advancing tumor only. So this advancing tumor is a dangerous one. Now in that advancing tumor, one red color portion is there. That is a necrotic tumor core. Here, this necrotic tumor core, in that there is no blood circulation. It's a complete dead cell. So this can be easily identified by the segmentation methods. So how this segmentation will help to us, just like a doctor's. That is happening because of deep learning techniques. So what is semantic segmentation? Semantic segmentation, before going to the semantic segmentation, let me clarify the classification, image classification, and then object detection. Then we will come to the semantic segmentation. In image classification, what happened actually, this image classification, we by using deep learning methods. Okay, by using deep learning methods, we use the CNN network to classify single object or a scene present in the image, whether, for example, if it is a dog, whether it is a dog or a cat or a whatever it may be, that as per that. So to classify that, after that, this will be the result. The classification is a very coarse and high level. Whereas object detection, what happened? We try to locate and classify multiple objects. Here, multiple objects will be classified under the object detection methods within an image just by drawing the boundary boxes around them. Okay, I will show that pictures also and then go for the classification. What is in the box? Next one. Now semantic segmentation. It is the most informative of these three, where we wish to classify. Yes, this is an important point. That is the difference between this semantic segmentation using deep learning method and classification using deep learning methods. Here we need to segmentation methods classify each and every pixel in the image. It is not happening in the classification, whereas in classification, entire scene has to be classified as a one object or like that. Whereas in semantic segmentation here, otherwise, how this is possible? There is an edema, there is an advancing tumor, there is a necrotic tumor core. See, if you observe this picture, this is the best example to understand that if the pixel by pixel classification is not there, it is impossible to identify the tumors. Tumor means all are not a complete dead cells. Advancing tumor is there again, and there are so many differences. Edema area is there. So it is possible only because of each and every pixel classification. This pixel belongs to this edema. This pixel belongs to advancing tumor. In that way, the segmentation network has to do. So this is possible by using semantic segmentation methods, by using FCN, fully convolution neural networks. Whereas in classification networks, we can use the CNN, convolution neural networks, to classify whether the given image is this one or that one or like that. Now, if you observe this, just for object detection, yes, this person 1 and person 2 are are in the boxes, and horse. There are 2 horses and 2 persons, and these 4 objects can be detected by first one by drawing the boxes around them, and then we will go for the next procedure. Now this is one more example. If you see that one man is there on the horse. Now first thing we have to extract the regions of this man and some other things are there around him. Horse and man. Let's consider this is a horse and this picture belongs to man. Now I'm extracting the only man picture. If this box is going for classification by using CNN, then the classification will give that options like this. Aeroplane, is it aeroplane? Is it a person? Is it a TV monitor? The CNN network will give that output. So this is an example. Okay, now coming to the segmentation methods. Are there any traditional image segmentation methods? The traditional, before going to explain the deep learning image segmentation methods, there are some traditional image segmentation methods which were very clearly explained in digital image processing textbook by the author Gonzalez. He has explained very nicely that traditional image segmentation methods are: one is thresholding method, another one edge-based segmentation, region-based segmentation, watershed segmentation, clustering based segmentation algorithms. So just I want to give a brief introduction about the threshold segmentation, because today's topic is mainly on segmentation. That's why I want to give segmentation. So segmentation is basically done by using detection of discontinuities and detection of similarities. Now threshold segmentation, what is the first step in the threshold segmentation? The image which is to be segmented is an input image. Now I have to calculate the histogram of this image just like this. For example, if there are only 2 regions, background is complete white and this is a black color. the center one is a black ball. This is an image. Then if I draw the histogram of this image, is like this, for example. Now the threshold segmentation is done by defining the threshold value, predefined. We have to predefine the threshold value. Then the resultant image, output image is defined like this. It is equals to 1 if f of x comma y. If this is an f of x comma y, input image is f of x comma y. If f of x comma y is greater than or equal to threshold value, it is 1. It is less. And then output image is 0 if this f of x comma y is less than threshold value. Means here the output is having only the two colors. Either 1 or 0 means white or black. So this is for binary image. Binary image is having only 0 and black colors. This is about the threshold. If you want, if any input image is having a multiple objects, we can go for multiple threshold levels. By selecting a multiple threshold levels, we can do this thresholding segmentation. And now the edge-based segmentation. Edge-based segmentation is based on point. Actually, there are three methods: point detection, edge detection, and line detection. Point detection, the authors have find only the one mask to identify whether this is a point or not. Whereas in line detection, there are different lines. So there are 4 masks have to be applied for identifying whether the given is a line or not. And that 4 methods: horizontal line, vertical line, diagonal line, I mean plus 45 degrees and minus 45 degrees. And finally, edge-based methods, edge detectors. Actually, they're basic. For basic explanation, these 3 authors have identified the edge-based detectors: Robert, Sobel, Prewitt. Yes, Prewitt for identifying the borders and edges, for detecting the borders and edges. These are very, very important masks for the segmentation. Under the edge-based segmentation. Okay, next one is a region-based segmentation. Yes, this is also very important. This region-based segmentation, is explained like this. For example, if this is an image, in this image, here also there are 2 methods: region growing method and region growing method and merging and splitting method. Region growing means just if you put a seed, then the seed will grow and it will connect that similar pixels only, similar gray levels only. That is called region growing method. And if it is now region merging and splitting and merging, in this method, first we have to divide the given image into 4 regions: R1, R2, R3, R4, and then we have to identify that whether this R1 is having set theory. R1 is this region is having all similar gray levels or not. That is important. Similar intensity values or not. If it is having, then P of R1 is said to be true. If any region is not satisfied, this one, if P of R4 is false, for example, if it is a false, means that region is not having the similar intensity values, then we are going to divide again R41, R42, R43, R4. Similarly, in this way, we have to check each and every region whether they have the similar pixels, similar gray levels or not. Then we have to divide it. Then after completion of the splitting, again we have to go for the merging. If any 2 regions are having the similar gray, for example, if these 2 portions are having the similar, like by checking the P of R1 union P of R2 is true. If these 2 regions are true, or P of R3, this is R3 and this is R4, R43. If this is true, then we can combine these 2 areas into one region. Okay, this is explained in the region-based segmentation. And watershed segmentation, it's a very important in identifying the breakage at the dams. Applying the watershed segmentation, we could able to identify the breakages in the borders at the borders in the dams, water dams. And next one, clustering based segmentation algorithms. These are the traditional image segmentation methods. Now, there are some advantages. See, these traditional image segmentation methods, they have used their knowledge of digital image processing and mathematical calculations. Coming to their advantages, the calculations are very simple. Okay. And the segmentation speed is also fast, but there is no guarantee of accuracy. We cannot give an accuracy. So that's why we should go for deep learning methods. Neural networks for segmentation, it's a more accurate method. So under this also, fully neural networks methods are very advantageous. Okay. And these are the basic semantic segmentation using convolution. Just for a pictorial view, I want to show that what is happening in the convolution neural networks. See this convolution neural network, if you see this, this is a input image and see this is an output image. The output image, this is a tumor identified. OK, this one, this will be done by the segmentation methods. And now in this session, I want to explain what is going in between this. So this is, if you observe the sizes of the boxes here, the size of the box is reduced and then again it is increased. That is, it may be done by U network. That is called contraction and extraction. So how can you reduce the size of the image? Obviously by doing the downsampling. Downsampling by removal of pixels. And here how can you again extract this? In the contraction portion, we have to go for the use of downsampling, and extraction portion we have to use the upsampling. This is these two steps are very, very important in image segmentation using deep learning methods, which is not used in normal CNN. This is one more example. This is a X-ray of our chest area. This the segment to segment these two portions here. This is a just for a pictorial view only. I have shown this one. I'll explain one by one. See the words. Some important words are there. Polling layer and upsampling layer, softmax layer, and all these words will be explained. And this is for colorectal tumor. And this is for breast cancer. UNet is preferred for image segmentation of the breast cancer. And see, in this one word is there, density estimation, because UNet has that advantage, density estimation. Density is improved here. And now coming to the medical images. These are the medical images. We already know about it. CT, MRI, PET, UI, and some medical images are also there. The microscope image. What is advantage of this? See this microscopy image. It's image of our blood samples. Okay, in this microscopy, we can go for the malaria parasite detection. Malaria parasite detection. Here also we can use the segmentation methods for identifying for segmenting the red blood cells and white blood cells. And in this malaria parasite detection. So these are the various medical images. In these medical images, this image segmentation using deep learning methods plays an important role. And retinal images also. There is a lot of research was going on in the retinal images, microscopy for a malaria parasite detection. Example, I'm telling only. UI ultrasound imaging. There is a very useful information in medical images. Doctors use CT and other medical images to judge the patient's condition, which has gradually become the main basis for doctors' clinical diagnosis. Compared with the traditional machine learning and computer vision methods, deep learning has a certain advantages in segmentation accuracy and speed. Yes. Now coming to this, medical image segmentation uses this set theory. Already I have explained in the region-based segmentation. Set theory, under this set theory, as I told you, that similarity and dissimilar. Similar and dissimilar means here this indicates that similar. Union of Rx is equals to 1 means that indicates that region is having a similar gray levels. And this, what about this one? Rx intersection Ry means there are two different regions. That intersection is equals to 5. 5 means null, means these two regions are said to be a mutually exclusive. That means they have no common elements. So in image processing, in a segmentation, we want to do the segmentation means we want to partition an image into different regions. Different regions. Each region should be the different. Then only we can call these as the different regions. So if this region and this region is there means definitely there should be no common elements between these two regions. So search entirely based on set theory. True and false. As I told you, that P of R is true means that one. That they're having the similar gray levels. And now the process of medical image segmentation can be divided into the following stages. How this process is going on. The first one, obtain the medical image, you all know about this. Obtaining the medical image data set. Generally, it includes the training set, validation test set. The train set is used to train the network model, and the verification test is used to adjust the hyperparameters of the model, and whereas the test set is used to verify the final effect of the model. Then after getting this image data set, what is the next step? We have to go for the pre-processing networks. Pre-processing networks, image pre-processing means what things can be done in this pre-process based on the requirement. Image rotation, scaling, and sometimes we may apply the filter to remove the noise, and all these things have to be done under the pre-processing and expanding the image. Okay. And use the next one, third step is use appropriate medical image segmentation method to segment the medical image. And the estimation performance evaluation. In order to verify the effectiveness of medical image segmentation, effective performance indicators need to be set to be verified. This is an integral part of the process. Now coming to the overview of the deep learning network. So if you observe this picture, is there any difference between machine learning and deep learning? So this feature extraction and classification, and here the feature extraction is done by this human beings in machine learning. The deep learning, everything is done by these neural networks only. And now there is a little bit explanation. I think it's not necessary. And medical image segmentation based on deep learning. CNN has been used in medical image segmentation in recent years. It has achieved great success in the field and auxiliary diagnosis. So this, as I told you, that starting slide in the content slide, I have shown these contents, which will be this session. Now coming to the CNN directly, CNN is a neural network with some convolution layers. The convolution layer has a number of filters that does convolutional operation. What is meant by the convolution? Is there any different convolution techniques are existing here? Yes, so there are some different convolutions are there in deep learning. Address convolution, that is called as I forgot that name. I will explain. There are 3 different convolution techniques in the deep learning methods. This is a whole CNN picture. Here in this convolution max polling, we can do the number of times as per our requirement. Here this is our input image. Now we want to classify this whether this is a cat or a dog. So here the convolution CNN max polling, convolution max polling, and now here flattened. So what is max polling? How the convolution is implemented here, how the max polling is implemented, and how this flattened, what is flattened, and what is the fully connected feed-forward network. Each and everything will be explained here. And now coming to the convolution neural networks. Yeah, this will be explained directly with the help of this figure. This is a neural network picture. Every neuron is like a processing unit. Now, a few parameters that define a convolution layers are, first one, kernel size. Please remember that these segmentation methods, there are some segmentation methods as per my slide, previous slide, fully convolution neural networks. Under this, deep lab V1, deep lab V2, V3, V3 plus, and UNet, and all these things are there. And these are different from each other only based on these factors. See, kernel size, if you understand these words, then we can understand easily that convolution. Kernel size defines the field of view of the convolution. A common choice for 2D is generally 3 by 3 pixels. 3 by 3 kernel size is preferred here. Stride. Here, I will show this difference between stride 1 and stride 2. This is about the padding and input and output channel. Number of input and output channels are equivalent to this featured maps. And different types of convolutions in deep learning are dilated convolutions. You can call it the address convolutions. This is mostly used in deep lab view. V1 FCN networks. This, remember that this is a dilated convolution is used in FCN networks and in deep lab V1 method, first version method, and then V2 also FCN is, address convolution is used. Next one is transposed convolution, separable convolution. Convolution is explained with the help of these input images. For example, one image is there, color image. Color image has 3 channels, red, green, blue. And each and every channel input image is like this, ones and zeros. It is of 6 by 6 image. And let's consider the 2 filters. 2 filters are there. Now, this is an input image, 6 by 6 image. And now filter 1 and filter 2. These are the network parameters to be learned. Here we have to apply the filter 1 and filter 2 and forgetting the featured maps. So here this picture will give the clear explanation about the convolution. See how this dot product is applied. Generally, we know that if this is a filtered image, kernel W1, W2, W3, W4, W5, W6, W8, W9, and if this is a sub image of our input image Z1, Z2, Z3, Z4, Z5, Z6, Z7, Z8, Z9. Kernel size and subimage size should be equivalent to 3 by 3 because the center of the filter should be on the pixel which is to be convoluted, which is to be filtered. So then the output of these two is sigma WZ. Or simply we can write W1 Z1 plus W2 Z2 plus and so on W9 Z9. This is a procedure. Now as per that procedure here these things will be explained. Stride 1. Here stride 1 means see the difference, but now the stride 1 and stride 2 difference is explained in this slide. This is stride 1. For stride 1, for example, the first pixel 1 is to be convoluted here. This one, the center of this mask should be kept here. So center of the mask is here. For stride 1, for the next pixel, this it should be on the 0 only. So it's shifted like this. For the next one, the output is this one. First one for first pixel, the output is 3. And here in this convolution networks, we are neglecting the borders. That's why I'm keeping the only this mask on this pixel 1, rounded pixel. Then output is 1. How I'm getting this output as a 1? So you all know about that, the multiplication procedure. See the 1 into, see this 1. One into 1 plus 1. And here remaining all are zeros in the input subimage. So no need to go for the calculation. Here only the center diagonal 1, 1, 1. All 3 ones, 1 plus 1 plus 1, 3. This is the resultant. And next one, stride 1 only. If the center pixel is 0, then if you keep this mask on this one, the resultant will be -1. If you do the product and addition, then we will get -1. Now, if stride 2 is there, then here it is shifted to the next position. Skip the position. First one in stride 2, the pixel which is to be filtered is 1 here. In stride 2, what's happening actually? This is the subimage now for first case, and second case actually it should be the subimage, but here in stride 2, this is the subimage. This is the case here. Here it jumps from here to there here. See, if you observe this picture, this one, the output will be -3. Only 2 outputs will come here. And stride 1, we will get a 4x4. This is called feature map. This is for filter 1 and this is for filter 2. Yes. Filter 2. Now, convolution versus a fully connected network. Convolution, what's happening in this convolution? Here, we are giving an input image, but we are not connecting all the neurons in input image. Actually, how many neurons, how many pixels are there? 36 pixels are there. But in this, we are connecting only first subimage 9 pixels only we are connecting to get the first value. Whereas in fully connected, all 36 pixels as a input neurons connected to the new hidden layers here. The all 36 inputs have to be given as an inputs. That is the difference between fully connected and convolution neural networks. So you see this filter 1 is applied on the first subimage. Then how many pixels have connected here? Here only these colors, red color, orange color, yellow color, as per the colors, only 9 inputs. Not fully connected, not all 36 are connected here. So similarly here, okay. Now coming to the max polling. What is max polling? Here now, after applying this filter 1, we are getting this featured map. After applying the filter 1 on input image, we are getting this as a resultant. In max polling, what is going on? In max polling, it's just like a downsampling. In downsampling, we have to remove the alternate pixels actually. In downsampling, as per procedure, we have to remove the every alternate pixel. But here in max polling, it's not like that. It subdivides the image into subimages and then it selects the maximum value in that box. See, the 4x4 image is divided into 4 subimages, like a 2x2. And in that first subimage, maximum is a 3. And second subimage, maximum value is 0. Because remaining all are minus. And here +3. Here in this last 1 is the highest value. So now the output of this max polling for a filter 1 is 3031. Similarly here, this is the result for filter 2. So now why the pooling is important here? We are doing subsampling. Is there any loss in this image by doing this subsampling? Because we are removing the samples, pixels. So is there any loss? So this in this polling, subsampling pixels will not change the object. See, this is an example. And subsample the pixels to make the image smaller. Instead of resizing this in convolution networks, they prefer the polling, that is max polling, by selecting the maximum value in that 2 by 2. For example, if a 4 by 4 is given as an input to the max polling, then this 4 by 4 is divided into 4 2 by 2 networks matrix, and this 2 by 2, out of the 4 pixels in the 2 by 2, maximum value is selected. CNN compresses fully connected network into 2 ways. By reducing the number of connections, shade weights on the edges, max polling further reduces the complexity. And here, this is the final output of max polling. Now we are getting the new smaller images. Whereas in segmentation, like again, we have to do the upsampling, and we try to make that upsampling image equivalent to the input image. That is happening in the fully convolution neural networks. If you want to do the upsampling, what is the procedure? Now we are removing simply by selecting the maximum value. And if you want to do the upsampling, if you want to increase the size of image, is there any procedure? Is there any procedure here? Yes. This upsampling can be done by using the three methods that is called as interpolation methods. Interpolation here. Upsampling can be done by using interpolation methods. Interpolation. This interpolation, there are 3 different interpolation methods are there. Here, how can you add the extra pixels? Without using any formula, we cannot add. But there is one method, that is neighboring. Based on neighbor pixels, we can add. Based on 2 more procedures are there, bilinear and bicubic methods. These 3 methods are there for upsampling. We will discuss later. Yeah, this is a whole CNN, the convolution max polling. And convolution max polling, the first resultant is a new image, a small image. Now we are getting the 2 by 2 image after max polling. Okay. And now there is one more new word here, flattened. After max polling, flattened. Here max polling convolution combinations can be done in any number of times as per your requirement, as per your application, based on your application. Now flattened. What is flattened? Now after see I'm explaining about the flattened only, not fully connected. The flattened. These are the results of max polling. These results of max polling here, because of since we are using the 2 filters, now we are explaining for 2 filters. We are having the 2 matrices, 2 by 2, 2 by 2 matrices. First, blue color indicates for the output of filter 1, white color indicates the filter 2 output max polling. Now we are trying to arrange all these outputs in a vertical, in a one line. Okay, now we are going to use the fully connected networks. Fully connected means each and every neuron has to be given as each and every input has to be connected as an input to the another neuron. So like this. If, for example, here after max polling, what is the size of matrix here? 2 by 2 only. So if you arrange the 2 by 2 matrices, total 8 only are here. But in fully connected network, what should be happen here? From every input we have to connect like this. This is called fully connected network. All inputs are acts as an input sources here, nodes here, and they should be connected to the neuron in the next layer. Deep learning architectures for segmentation. A segmentation network is also actually it's also changed in the common CNN structure. What is the difference here? Deep learning architecture for segmentation. Here now we are I'm going to explain about the segmentation here. Deep learning architecture. So till now we have discussed about the CNN structure. There is a change in the CNN structure and segmentation neural network structures. What is that change? At the output, we are using the fully connected network in the previous. Here we are using the fully connected. Instead of using the fully connected, here fully connected is used for image classification actually. In CNN, we are using the CNN for image classification. That's why we are going to use the fully connected at the end of the max polling. Okay. Now, for image segmentation, we need to classify each and every pixel. We need to classify each and every pixel. So the each and every pixel cannot be able to classify it by using this one-dimensional. So that's why we have to go for the use of again convolution networks at the end of the max polling. Instead of using fully connected networks, here in segmentation methods, we have to use the convolution networks. So what is the difference between fully connected networks and convolution networks? Again, already I explained these two. So now see, the first segmentation network was to change last two fully connected layers for the classification network to the convolution layers. Segmentation network was to change the two fully connected layers for the classification network to convolution layers, which are used in a classification network. Now we are removing for segmentation. If we want to use the CNN for segmentation, we are removing that fully connected layers and we are using the convolution layers. Okay, that is only the difference. And these are the following networks used for segmentation. These are the actually earlier versions. LENet, that architecture consists of two sets of convolution activation polling layers followed by fully connected layer activation, another fully connected, and finally softmax classifier. These are some networks, already existing networks. AlexNet, VGGNet, RES nets mean residual nets. These are used for medical image segmentation. Dense nets, mobile nets, NAS nets. These are the various segmentation networks. Here in image segmentation model, even though these are said to be an early networks. Here this is an early network, VGGNet. In image segmentation, deep learning based image segmentation model, here we are using the VGGNet as a basic structure for one of the medical image segmentation using deep learning method. It is used as a basic network structure, VGGNet. And similarly, residual networks are also used as a basic networks for one of the latest image segmentation networks. So the medical image segmentation based on deep learning, the CNN based CNN has been used in medical image segmentation in recent years. It has achieved the great success in a field of and accelerated diagnosis. Yes. Fully convolution neural networks. Now I want to explain. That's why I'm showing this slide once again. FCN and UNet and GAN, generative adversarial networks, or the various image segmentation methods. Now under FCN, again there are 4 methods: Deep Lab, V1, V2, V3, V3 plus, Signet. All are advanced ones. And then again, each and every one has their own advantages and disadvantages. UNet is a mostly used segmentation method in the present days. UNet and VNet, that name itself indicates their shape of the network, U shape and V shape, for a contractions and extractions of these kernels, max polling and all these things. Yeah, coming to the FCN. FCN is an advanced deep learning technology for semantic segmentation. As I told you, that the FCN, there is a difference at the end. Whereas in the convolution neural networks, which is used for classification, at the end we are using fully connected networks. Instead of using fully connected networks, here we are preferring the convolution networks again. So if you observe this is for a general classification CNN network such as a VGG and residual nets, some fully connected layers are added at the end of the networks. As usual, CNN structure is generally the CNN structure, for example, if it is a first five layers for convolution layers, 6th and 7th layers are fully connected layers, and 8th layer is a fully connected layer. And now the category of this entire image can be identified. The category of the entire image can be identified, not the category of each pixel due to one-dimensional probability information. What is this actually? Here, for image segmentation, we don't want the category of entire image. If you consider the medical image, we don't want the entire image classification, because medical image, the abnormality is identified in a particular region only. As per our previous example, brain tumor, the entire image is not spoiled actually. Entire brain is not spoiled. Only in a particular area there is an abnormality with the edema and advanced tumor and dead cells. So that entire image classification is not useful for the segmentation. But in segmentation, we want each pixel classification. It is not possible by the CNN structure. This is not possible because of the one-day probability information. So the fully connected method is not suitable for image segmentation. So now what are the changes in the FCNN? As per the previous example, the 3 layers, 1 to 4 is okay, and 5 to 7 are changed into convolution layers. 5 to 7 are changed into convolution layers here. Whereas in the previous slide, what is there here? 5th, 6th and 7th are convolution fully connected networks. 6th and 7th are fully connected networks, neural networks, and 8th is also fully connected neural networks. Now in FCN, they have changed the from 5th to 7th as a convolution layers, whose convolution kernel sizes are 7 by 7, 1 by 1 and 1 by 1, so as to obtain 2-dimensional feature map of each pixel. This is very important. Then it is followed by softmax layer to obtain the classification information of each pixel. The segmentation problem is solved now, because we can able to classify the each pixel by using this modifications. The fully convolution network can accept the input images of any size. The FCN uses the deconvolution layer to upsample the feature map of the last convolution layer and restore it to the same size of the input image. Yes, already I told this. The FCN uses the deconvolution layer to upsample the feature map of the last convolution layer and restore it to the same size of the input image. For example, if I consider the unit also followed the same thing, or in the early figures, the convolution network size is like this, and then again we have to go for upsampling slowly like this. First we have to do the downsampling, then we have to go for the upsampling. So deconvolution layer, FCN uses the deconvolution layer to upsample the feature map. This upsampling is done by using interpolation methods, because already we are removing the samples. For example, if it is a 4 by 4, we are removing the samples by using some max polling or whatever it may be. That 2 by 2 is now the image size. Now we have to increase this 2 by 2 to 4 by 4. How can we do this? Already we removed, no? So we have to add the new pixels 4 by 4. How it is possible? By what techniques it is possible? That is added here in FCN. That is called the deconvolution. Here by using the convolution, we are going to reduce the sizes, and now we have to go for the deconvolution. For what purpose? Again, we want to restore our output image as the same like an input image. Thus, the prediction can be generated for each pixel while returning the spatial information into the original input image. Finally, pixel by pixel classification is performed on the upsampled feature map to complete the final image segmentation. Pixel by pixel class. This is our goal, our aim in image segmentation, medical image segmentation. We want the pixel by pixel classification. Yes. There are some shortcomings of FCN. These are the shortcomings. First, the results of its samplings are relatively fuzzy and insensitive to the details of image, resulting in the segmentation results not being fine enough. The second one, the idea of segmentation is essential to classify each pixel without full consideration. The relationship between pixels and pixels lacks the spatial consistency. Yes, this is a major drawback in FCN. In order to get the denser score map, in order to get a denser score map in FCN, the authors added the padding to the first convolution layers. The padding size is equals to 100, which will bring a lot of noise. So this FCN here, the denser score can be obtained in a unit. This is a very important thing. The denser score map, it is a limitation of FCN, then it will be overcome by the unit maps, unit network segmentation methods. Okay. Now coming to the first method of Deep Lab V1. The fully convolution neural networks, Deep Lab V1 is the basic first fundamental version method. In that method, what are the changes here from the CNN? What are the changes here from CNN? They have changed the polling stride from original 2 to 1. Actually, we discussed in the previous slides what is the striding. The striding means, for example, if this is an image, with some pixels, for example, if I want to apply on the first pixel filter kernel or a filter to be applied on the first pixel, now the first filter center of the filter should be at the pixel which is to be filtered. For example, if this is a filter to be convoluted. Now in a stride one, what happens actually? Stride one immediate next this one, but this is for stride one. What about the stride 2? Stride 2 we have to skip for this. Yeah, in stride 2, first sub filter has to be applied on this one. Second one, we have to apply the filter on this one. Yes, we have to skip this line. That is stride 2. Now in unit, Deep Lab V1, the stride from original 2 to 1. I mean, previously stride is 2. Now it is shifted from 2 to 1, means obviously it's an advantageous thing, because instead of skipping that one line, it will we will lose the information now. So the padding size from original 100, whereas in FCN padding size 100, now for padding size original 100 to 1. I think you all know about the padding. In convolution, we have to do the padding at the borders and edges, because there are no pixels at the borders and edges as size like a kernel or filter size. So then at that time we have to pad the elements with the zeros. And this way the size of polled image is not reduced and the score map result obtained is denser than that of FCN. Yes, better, somewhat better. A score map result is somewhat denser than the FCN. Deep Lab V1 is rewritten based. Yeah, I told you know that VGG network is a fundamental network, a basic old version networks. Segmentation. This is one of the segmentation network, VGG network. Deep Lab V1 is a rewritten based VGG network, removing the last fully connected network layers of VGG network and using the full convolution. That is important here. So the authors removed the last 2 polling layers and added address convolution. Here, this is one more important thing here. Till now we have discussed the convolution. Generally, normally we are using the word convolution, but here the convolution, there are 3 types of convolutions. Address convolution is there, first method. Address convolution, they have used the address convolution by removing the last polling layers. Then compared with the traditional convolution, receptive field can be expanded without increasing the amount of calculation, and density of features can be increased. And finally, Deep Lab V1 uses conditional random field, CRF. It's important for remaining methods also. Deep Lab V1 is also followed that CRF, whereas V3 is also followed this one, but UNet have removed this CRF. Deep Lab V1 uses the CRF to improve the accuracy of segmentation boundaries. Now Deep Lab V2. This is an extension, actually, this is an extension version of Deep Lab V1. See, the importance of Deep Lab V2 is, for example, if I have an image, for example, if I have a two scenes in this image, the two scenes are same but of different sizes. Two scenes are same but of different sizes. Then in traditional networks, what we are doing, we are trying to resize this into this size and we are doing the segmentation. But in Deep Lab, what is missing in that? When we are trying to resize that image, definitely we have missed some features, important information. Okay, so that is not happening in the Deep Lab V2. That is not happening. What is there in the Deep Lab V1? In Deep Lab V1, striding changed from 2 to 1 and polling is also the denser will be increased. But here Deep Lab V2 is especially it is used for these cases. If any two objects are of the same type with different sizes, in that particular case, we are preferring this Deep Lab V2 by using their features. Deep Lab V2 is an improved based on Deep Lab V1. It solved the difficulty of segmentation caused by differences of the same object scale in the same image. Same object scale in the same image. So actually what's happening in the traditional methods, when the same thing has different sizes in the same image or different images, the traditional method is to force the image to the same size by resizing, but this will cause some features to be distorted or disappear. The contribution of Deep Lab V2, it lies in the more flexible use of, here also it uses the address convolution, or you can call it as a dilated convolution. See the convolutions, all convolutions are not same. There are some 3 convolution methods. Address convolution, transitional convolution, one more convolution is there. And the 3 convolutions already listed in the previous slides. Address convolution is preferred in Deep Lab V1 as well as the Deep Lab V2. Dilated convolution, which proposes the address spatial pyramid polling. Which proposes the address spatial pyramid polling. Yes, if you observe this, I could not able to give the explanation of all these things because the time is very less. And here address spatial pyramid polling here, if you observe the picture, this is like this one. This pyramid structure is, I could not able to draw this view actually correctly. For example, if the filter is applied here in this pixel, next it is moved from this one to this one, next it is moved from, this is explained like this. This is moving from this one to this. In like a convolution, we are doing mathematically the convolution operations, multiplication and addition. Here also it shows the pictorial view like a pyramid structure. Okay, address spatial pyramid polling is proposed by this address convolution. Address convolution which proposes the address pyramid spatial pyramid ASPP. What is the advantage of this? The continuous polling and downsampling of deep convolution layer DCNN causes the resolution to decrease. And Deep Lab V2 here, it removes the downsampling in the last few maximum polling layers. This is very important here. It removes the downsampling. It removes the downsampling and it adds the convolution. Instead, it uses the convolution networks. Convolution networks are of the type address convolution networks to calculate the feature maps. So then they can increase their sampling density with a higher sampling density. So this is the special feature of Deep Lab V2. They remove the downsampling and instead of the downsampling, they have used the convolution networks or of dilated convolution networks. They also removed the fully connected layer in the network and replace it with the fully convolution layers. Okay, this is obviously happening in FCN networks. Fully connected layers are removed by there are no fully connected layers in FCN types. They all are removed with the fully convolution layers. And instead here, the special case of DeepLab V2 is downsampling is also removed here. And now DeepLab V3 and V3 Plus. Here, DeepLab V3 is continue to use the residual network. The aiming at the problem of here multi-scale target segmentation. This is the specialty of DeepLab V3. Multi-scale target segmentation. A cascaded or a parallel address convolution ASPP module is designed here. This module detects the convolution features on multiple scales and uses the image level features to encode in global context to the further improve performance. So what is this multi-scale target segmentation? Why should we go for that multi-scale target segmentation? Where it is required? That is very important. But they have performed this by using a cascaded or a parallel address convolution ASPP module, which is used in DeepLab V2. Address convolution was used by DeepLab V1 and V2 instead of fully connected networks. And here the address convolutions can be used for multi-scale target segmentation. And the DeepLab V1 is using they have used the VZZ net. Earlier network model VZZ net. But whereas in DeepLab V3, it uses the residual nets, 101 network. This is about the DeepLab V3. Now V3 Plus. Yeah, DeepLab V3 just it removes the CRF. Previously DeepLab V1 and V2 they have used that CRF. Now they have removed it. There is an improvement in DeepLab V3, significant improvement over the previous DeepLab versions. And however, DeepLab V3 also has some shortcomings. Example, zooming effect of output image is not good because it is a very little zooming effect is very little information. And now DeepLab V3 Plus extended the DeepLab V3. It added a simple and effective decoder module to refine the segmentation results. Okay, especially the segmentation results along the target boundaries. And the last in this FCN is SegNet. The FCN, this is about the SegNet. SegNet builds an encoder and decoder symmetric structure based on semantic segmentation tasks FCN to achieve the end-to-end pixels. It uses the VZZ network only. And coming to the UNet model, this is important. UNet model for segmentation. Yes, there are again two types, 2D UNet and 3D UNet. Just I want to focus on 2D UNet only. A 2D UNet, what is the specialty of 2D UNet? See, if you observe the picture of UNet, this one. First, please go through this picture and then we can understand easily about the terminologies present in that UNet architecture. What is happening? What is happening in this UNet structure? Anything special? Is there anything special than these convolution neural networks? First one is an input image. And next one. This red line indicates the max pooling. This red line indicates the max pool of 2 by 2 size, 2 by 2 size only. Whatever may be the input image size. For example, this may be. Sorry. So for example, if this is the size of an input image, after convolution, this is an input image size. After convolution, if we neglect the borders and edges, these are the feature maps. So as per our example, 6 by 6, and this is a 4 by 4. Then after max pooling, what is the size here? We are getting 2 by 2 only. But based on the number of filters, we are getting the number of channels. Okay. Number of channels are equivalent to the number of filters only. So the input and output channels are based on that. Now max poly. Again, here, this is only for 6 by 6. We are taking this example for understanding purpose, but the size of the image is 572 by 572. If you go for that with the max pool of 2 by 2, how many max pools are required here to reduce the size downsampling, to get the downsampling as per our requirement? So here they have shown few max polling sessions, and this blue color again, it is a convolution of 3 by 3 RELU. This is a convolution and rectified linear network. RULE means rectified linear networks, and that is there in the unit architecture. Again, see, if you observe this picture, here again, it's just like a FCN. After completion of, after this downsampling, every time they have used the CNN convolution. Here also convolution, max polling convolution, max polling convolution. And next, they have started this upsampling to increase the size of the. Now, for example, if it is a 2 by 2, here now it will become a 4 by 4. Again, it is an edit. Just it try to make it is equivalent to the input image. The green color indicates the upsampling. The output segmented image. Now these two sizes are almost equivalent. Okay, this is the procedure happening in the unit network architecture for an image segmentation. This is very, very important because in medical images, we want the pixel by pixel classification. This is happening by using this FCN only. And finally, here also, see at the output image also, we are having the convolution. This blue color is for convolution, not for fully connected. We have not used the fully connected networks here. That is only the difference between this one and classification, image classification and image segmentation. So shall we go through this 2D unit, because unit is an important one for image segmentation. Unit is a convolution neural network that was developed for biomedical image segmentation. The network is based on fully convolution network and its architecture was modified and extended to work with a fewer training images. And see, if you observe this, this is called a contraction and this is called a U shape. Downline shows the contraction and this is called an extension. So segmentation of 512 by 512 image takes a less than a second on a modern GPU. Say if you want to perform this segmentation by using, for example, Python, then on modern GPU, this 512 by 512 process. See, to do this 512 by 512 image segmentation, we are thinking that 6 by 6, it requires the 2 or 3 steps of the max per one step. So similarly, if you do like this 512 by 512, how many steps are required to do this one? But in image unit, by using the unit, it takes only all these steps can be implemented within a second, less than a second in a modern GPU. That is an advantage of unit. Okay. Main idea is to supplement a usual contracting network by successive layers where polling operations are replaced by upsampling operators. Polling operators here also, just like a deep lab V1, V3. Polling is replaced by upsampling operations. Whereas in that, polling operations are replaced by convolution networks, but here they are replaced by the upsampling operators. Hence, these layers increase the resolution of the output. That is very important here for segmentation. Then only we can able to see the picture with a clear clarity. Okay, one important modification in unit is that there are a large number of feature channels in the upsampling part, which allows the network to propagate the context information to higher resolution layers. The expansive path is more or less symmetric to the contracting part and yields a U-shaped architecture. It's almost opposite to that of the contracting part. This is a unit network architecture. It consists of contracting path and expansive path, which gives it the U-shape architecture. What is the specialty of U-shape architecture here? As per these discussions, U-shape architecture removes the pollings with the upsampling. Polling is replaced with the upsampling. This is a very important case in this unit. And the contracting path is typically convolution network that consists of repeated applications of convolutions, each followed by RELU network, that is rectified linear unit and max polling operation. During the contraction, the spatial information is reduced while feature information is increased. Yes, it's a very important. Why it is happening like that? Spatial information is reduced. Feature information is increased. How it is happening? Spatial information is reduced because we are removing the pixels. We are removing the pixels from, for example, 6x6 image. After convolution, we are getting 4x4. Then after max polling, we are getting only the 2x2. Spatial information is removed here. And while feature information is increased here by doing the upsampling. The expansive pathway combines the feature and spatial information through a sequence of upconvolutions and concatenations with a high resolution features from contracting path. This is about the 3D unit. Just it's like a U-shaped network. The segmentation of MRI images, a brain tumor, as already we explained in the first slide only. And unit applications. These are the unit applications. There are many applications. In biomedical image segmentation, such as a brain image segmentation and liver image segmentation. And variations of the unit have also been applied for medical image reconstruction. So here are some variant and applications of units as follows: pixel-wise regression using unit and its applications on pan sharpening. 3D unit application is found in learning dense volumetric segmentation from sparse annotation. And this is Turner's net unit with the VZZ11. VZZ is a fundamental image segmentation network. Now all this latest technology, advanced technology, they followed that VZZ and they have done their modifications on VZZ only. Encoded and pre-trained ImageNet for image segmentation. And this is about the VNet. VNet means this comes under UNet only. It uses the dice coefficient loss function instead of traditional cross entropy loss function. Instead of traditional cross entropy loss function, these functions are used in deep learning techniques. It uses the dice coefficient loss function. Okay, and this is a VNet. This is about the VNet. The shape itself and gives the same convolutions and max pollings. And the last one, generative adversarial networks. There are two networks here, discrimination network and generator network. If you observe this picture, we can understand the real images are applied to the discrimination networks and fake images also. Now we have to predict the labels. That is important thing here. These are the algorithmic architectures that uses the two neural networks pitting on one against other in order to generate a new synthetic instance of data that can pass for real data. They are widely used in image generation, video generation, voice generation. The generator takes in random numbers and returns an image. The generated image is fed into discriminator alongside a stream of images taken from the actual and ground truth dataset. The discriminator takes in both real and fake images and returns the probabilities, a number between 0 and 1, with 1 representing the prediction of authenticity and 0 representing the fake. So this is information about the GANs, generative adversarial networks. And with this, I want to conclude my session. And thank you so much for giving this opportunity. If any queries are there, please ask me. Sir.
Madam. Very nice presentation, madam. Let us give some time, 1 or 2 minutes for the people to ask the questions. Participants, you can raise your question to madam. Madam is online. Okay, we will give you 2-3 minutes, you can ask madam the questions which is related to the today's topic, neural networks, convolutional neural networks, and based on this machine learning and image segmentation. Participants, you can raise your questions. We'll give you 1 minute time. If no question is there, I hope that we can close the session. Yeah, someone is raising their voice. You can raise your questions, please. Hello.
Participants can ask any questions.
Because it's purely the research, she has given the presentation on her research topic. It's purely her research topic. So she can give you an in-depth answer for whatever the questions you are asking. Okay, participants.
Okay, sir. Sir, thank you
yeah.
so much, sir. Thank you so much for giving this opportunity.
Welcome.
Yeah,
Welcome, ma'am.
thank you, madam, for your valuable information. You have given thorough applications of convolution neural networks on medical image processing, segmentation, and different types of convolutions, and stride and max pooling, such kind of concepts you have explained very well. And you have explained the downsampling and upsampling of convolution neural networks in medical imaging segmentation, and the significance of convolution neural networks, how the era is changed from traditional machine learning to convolution neural networks. Very good informative session, madam. Thank you very much.
Thank you, madam. Thank you.
Thank you, sir. Thank you so much.
Thank you very much, madam.
Thank
Thanks
you,
for
sir.
your contribution. Thank you. Yeah, next session will begin by 6 o'clock. All of you, either you be there in the session itself. It can be continued with the next session. So anyhow, the second session will start by 6 o'clock. Okay, thank you.